everyone, welcome back. For this video, I'm going to be going through assignment 4. So we're going to start in our file directory. You should have something that looks kind of like this. And remember, one of the useful ways in which we can just easily set our file path is to start by opening up a previous R Markdown file that is located in the same place we want to save all of our stuff. So go ahead and open assignment 3. I'll then go ahead and make a new R Markdown file. Or save it as a Word. Okay. And remember, we get rid of all of this gobbledygook. Now, I'm assuming that if you're at this point in assignment 4, you've already gone to the website. So you've already seen and potentially done some of this stuff, and that you're kind of at this point where you need to start identifying levels of measurement, proportions, and start graphing things. So that's where I assume you are. I also assume that you've watched the lecture video for this week, and that you've done the readings as well, which means that you should be familiar with things like skewness, rates, percentages, proportions, and the types of graphs that are appropriate for different levels of measurement. So if you haven't done that, I recommend going back, doing that, and then coming back to this video. So the part 1 of our instructions has us, again, just opening up an R Markdown file. We can then go ahead and save it. You can either press save. You can also use a hotkey. So in this case, the hotkey would be Command S for me on a Mac. But it would be Control S if you're on a Windows. I then want to save it similarly to the way I've saved the other ones. So the year, the month, the date, last name, the name of the course, 5, and then assignment 4. Okay. The next thing for part 1 is to put some headers in it. So part 1, assignment 4.1. Let me say this R Markdown document contains my work and for assignment 4, it is my work and only my work. If you need a brief refresher, remember that hashtags outside of code blocks create headers. So the more hashtags you use, the more headers you, or the deeper in the headers go. So this is a second level header. And also remember that a single asterisk around a word or a set of words will italicize those words when knit. 2 asterisks will bold it, and 3 asterisks will bold and italicize it. Okay, now we move to part 2, where our goal is to read in and identify some characteristics of the lone offenders assault NCVS dataset. This dataset details individual experiences with criminal victimization. If you want to know more about the dataset, there is some information on page 75 of your Bachman book. So the first thing we're going to do is make another second level header, part 2, assignment 4.2. But they're going to make a third level header called load libraries. This is always the first thing you need to do, is load in some libraries at the top of your page. Insert a code chunk, insert a code chunk. And then we'll go ahead and load 6 libraries. Tidyverse, Haven, here, SJ Miscellaneous, SJ Plot, and Summary Tools. And then remember, we have a bunch of different ways that we can run this code. We could run it individually, either by highlighting it and pressing run. Actually, that will run the entire thing. So if you press this little green arrow here, it will run the entire code block. If you want to just run one, you can press Control or Command Enter, and that will run each one. And those are sort of your two main ways to do it. You can also go up here and press either run selected line or run current chunk, et cetera, et cetera. So we've now loaded in our libraries. So now we are going to create another third level header called read data into R. Another code chunk. And what we're going to do, if you remember from the past assignments, we're going to create an object and then read that data into the object. So in this case, we'll call it NCBS 1992 to 2013. Remember, I use hotkeys to insert these assignment operators, where it basically takes the stuff on the right and puts it into an object that's labeled on the left. You can also just manually type, but I prefer hotkeys. So read SPSS. Remember, I am pressing tab when I want it to autocomplete for me. You can also, press enter, and it'll do similar things. Here, data sets, NCVS, loan offender, assaults 1992 to 2013.sav. And sometimes I like to just run this bit to make sure I've written it correctly. Cool, so I've written it correctly, it works. And so I'll go ahead and run the entire thing. And then you can highlight just this bit and press Control Enter. Just again to double check that it's saved to that object. The other way you can check is to go down into your environment and see that it's loaded up here as data with 23,000-ish observations and 47 variables. Another thing we can do to look at it is to just click on it and it'll pop up our data here. Okay, now we're going to create another third level variable called describing injured. Male off, age R, V2129 variables. So we'll insert another code block. Oops. And so the next thing we're going to do is create some frequency tables for these particular variables, because ultimately what we want to do is to be able to graph them, but we need to know their level of measurement. And one of the easiest ways to check that is to view some information from the data set and then actually plot the frequencies. So to begin, we're going to use the command, the data command to view data frame. So in this case, our data is NCVS. We're then going to pipe it to the view df command. And so we can see, we can check out injured, for instance, to find where that is. These are the names of variables. So we got to scroll down till we find injured. Okay, so this means that the victim sustained injuries during victimization, and it's a binary variable where 0 means they were uninjured and 1 means they were injured. We can do that for all of our variables. You can check down here to find male offender. So it's coded as 1 if it was a male offender, and 0 if it was a female offender. Now the next thing the assignment has you do is make some frequency tables. So the way we're going to do this is make a fourth level header and just call it something like a injured frequency. Insert another code block. And then remember, there's a couple of different ways we can make frequency tables. CVS. I'm going to use the freak with an E function from summary tools because I kind of like the output of it. And we'll start with injured. Okay, and so this is telling us that 67% of people did not sustain an injury, and the last 32% did. Recall that these don't tell us what these labels mean. And so if you prefer a table with labels, use the FRQ without the E and do this instead. And so it tells you your label here. So that's also pretty nice. You can really use either one. I thought I preferred this top one, but I actually like them both for different reasons. Okay, and we'll do this for the next one. Let's see, mail off frequency. Again, it's the same thing. You'll notice I keep doing this. It's because I'm using the wrong hotkey, and so it's trying to insert an assignment operator for me. But what I really want is a code block. And so again, NC yes, I press tab to autocomplete because I'm lazy. Let's do this one. Mail vendor, run. So again, you can see 20% were female and 79.98% were male. And here's the cumulative percentages. With these binary variables, that's not super interesting. But age, I think that's the next one. Age should be more interesting. Oh my gosh, blanking. There we go. NCVS, pipe again. Remember, if I ever do something fast like that, I am almost certainly using a hotkey. As a note, you'll see that RStudio will sometimes throw up errors for you. In this case, it's telling me that the document ends in a way that it's confused about because I've essentially tried to pipe to something, but I've not piped this to anything. And so it's like, hey, I have a problem with that. Age. Yeah, so this is a little bit more useful. So we can see the number of people who had experienced victimization in this data set at age 12 is 802, or 3.3% of the sample. And you can see that the cumulative percentages are calculated here. So for instance, 15% of the sample was age 16 or younger when they experienced the victimization reported in this survey. Similarly, we can say 51% were age 30 or younger when they experienced victimization. So this will be important later. Also, this tells you the mean age for this value and the standard deviation, which will be useful for us next week. So we've got one more variable to do. It is that numeric one. Let's see. NCVS, pipe, RQ, B21, oops. Make sure you use the right one. It just auto-completed the wrong thing for me. Okay, and so this tells us we can look at this here. We can also look at it over here, B2129, MSA status. That's still a little bit vague, but if you look at page 75 in your textbook, It describes that variable as a 3-category nominal indicator of where a person lives. It's based on the Metropolitan Statistical Area, MSA classifications, but loosely speaking, 1 equals lives in a city, 2 equals lives near a city, i.e. like suburbs, and 3 lives in a rural area away from cities. And so based on all of this, we can make some pretty useful guesses about what the levels of measurement are at this point. And so it's at this point in the assignment that I recommend you pop over to here. And so for instance, I will more or less give you the first one. So this injured variable, we can go back here and see that it's binary. So it's a 0, 1, and the categories are injured or uninjured. And so because of that, we can say that it is a nominal level of measurement. And I will leave you all to do the rest of these. Then we have question 4. What is the cumulative percentage of victims below age 18? Well, I just showed you how to find lost it. I've got too many things. Oh, it's because it went away. I made it smaller. Over here, you can find the cumulative percentage. And so all you need to do is figure out which line to look at to find the cumulative percentage of victims below age 18. So once you've answered these 2 questions, we can pop back and go on to part 3, assignment 4.3. So now that you know the level of measurement for each of your variables, we're going to go ahead and determine which graph you should use. So once again, we'll create a second level header. Good, this is still recording. Called part 3, assignment 4.3. And then we're going to make a third level header called graphing injured male off age R and V2129 variables. And so structurally, we're going to do the same thing that we did up here where we have these 4th level headers. But rather than plotting the frequency tables, we're going to graph them. So graph of injured, then insert a code block. Now, at this point, it is up to you to figure out which graph makes sense based on the level of measurement for each variable. So for instance, I basically just gave you that this was a nominal level variable. That means that probably our best graph for it is going to be a bar graph. So if that's the case, I've given you code for plotting a bar graph. But I'll reproduce it here, NCV, CVS, pipe, and this time we're going to pipe to a function called ggplot. Now ggplot is part of the tidyverse, and it makes nicer graphs. Ggplot, it's because I typed it wrong, ggplot, injured. And then you can put these all on one line, geom bar. You can put these all on one line. For readability, I like basically piping, and then piping will allow you to put something on a new line. And then with ggplot specifically, you can use this little plus sign to basically indicate to R that more is coming in your function, that a line break actually doesn't mean a new function. And so you can order things this way, and it just makes it nicer to look at. Like functionally, this will run the same as this. Oops, you type it correctly. So we'll run this. Thinking. It might give you this warning. Doesn't matter, ignore it. But you'll notice it's the same thing. Both codes run exactly the same way. It's just an aesthetic preference. So this is our graph of our injured variable. So we can see, again, most people are uninjured, but some people are. If we look back at our frequency table, go away, we can see that we've got an N of like 16,000 for uninjured and like an N of 7,800 for uninjured. And you can see that that's kind of where we're hitting here. We're a bit over 15,000 for our counts and a little over 7,000 for our injured counts. There are tons of other ways to make these look way prettier than they are, but we're not going to get into that in this class. Just know that you can do a bajillion more things with ggplot specifically. And so for the rest of part 3, you're going to basically do this for the rest of your variables. So you need to pick for male offender, age, and this V2129 variable, whether or not you should plot it like this as a bar graph, or I actually don't think it will let you do this if it's wrong, but we're going to find out. You can plot it as a histogram, and it will look like this, and it's your job to see whether or not that makes sense at all. But I'll tell you for this first one, it should be a bar graph because it is a nominal level variable. Oops. Okay, so I am now, you can go back here and tell me the appropriate graph, bar chart, or histogram for your following variables. Don't use the quotes, just type in this case, bar graph, but type it correctly, or bar chart. Bar chart, that's what I've told you to write. That's what you should write. You then need to decide based on the graph you make for age, the age R variable, if it's skewed. So if you don't remember what skewness is, go back to your chapter and reread or go to the lecture. Now, the last thing uses part 4 of the assignment, where we're going to recode the age variable into a binary variable, and then we're going to plot it as a bar graph, and then save that plot. Let's go back here. Part 4, assignment 4.4. Recoding and describing thick 18 and over min variable. Okay, so whenever you recode a variable, you need some kind of plan. You got to know what you're going to do with it. So in this case, we have this big age R variable. And as you can see, it's kind of, and I keep minimizing it because it's long. You can see this is super long. This is a super long output table. And you're like, you know what? I kind of just want to know whether or not victims were under age 18, so if they were legally not adults, or if they were over age 18, so legally adults. And so that's what we're going to do here is we're going to recode it into a binary variable where 0 means that the respondent was younger than 18 and 1 means that the respondent was 18 or older. Another thing to call these when you code this way is a dummy variable, where you've got these 0 1s. You can also call them indicator variables. And so to do this, we're going to use the mutate function from the dplyr package. We're also going to use the if-else function. So here's what we're going to do. NCVS. Now in this case, we're not going to immediately pipe. We are going to basically assign this next code that we're going to write to it. Oh boy. Come back. There we go. Pipe. You can then put this all on the same line. Again, I kind of like putting things on new lines when I'm piping. So you can't just willy-nilly put things on new lines. So for instance, I couldn't put this on a new line, but if you're piping, you can then put the next command on a new line. And so I tend to do that just, again, for aesthetic reasons. We're then going to use the mutate command. And mutate just creates a new variable. That's all it does. It's part of the tidyverse. There are other ways to do this in base R, but tidyverse just looks nicer. It's a little bit cleaner to use. We're then going to name our new variable. So in this case, it's going to be Vic 18 and over bin. You'll notice it wants you to autocomplete because there's a similarly named variable already existing in the data set. We're going to ignore that. And then we're going to press equals. And basically we're saying this variable name we're going to assign to the stuff that we're about to type out. And in this case, we're going to use the if else command. Note it's if underscore else, not if else. If underscore else is from tidyverse, and it does nicer things for us than if else without the underscore. I'm going to do age R less than 18, 0, 1. So what this is doing, it's saying, okay, take this age R variable. If there's a person in it that is less than age 18, recode that to a 0. Put a 0 there instead. If they're 18 or older, put a 1 there. And then for this entire thing that we're recoding, go ahead and put that entire variable in a variable called Vic age 8 or Vic 18 and over bin. That's all this code is doing. Then we will run it. So one thing, again, I tend to like to run just pieces of code before I assign it to something. So you can do this. It's not throwing any errors, which is useful. If we went all the way to the end, we'd see our variable here. You'll see it's actually identical to this Vic 18 and over that we've already created. That's fine. So it looks all good. So we'll go ahead and run the entire thing, which will both create this variable and save it to our pre-existing data set. Now we're like, okay, cool, let's see if this worked. And so we can do ncvs view df and scroll down because new variables are always created at the very end. And we can see our variable was created here, which means we have successfully recoded a variable into a new variable. So the last thing we're going to do is plot it because we can, make a frequency table for it if you want. So you can ncvs break Vic and over bin. I'm like, that's fine, but I like pictures. Pictures are worth 1,000 words and all that. And so what we're going to do is we're going to graph this as a bar chart, and I've given you the code to do that. In this case, it's going to be ncvs going to pipe to ggplot. Vic 18 and over bin plus geom. Whoop. Bar. And we have ourselves a nice little plot here. So we can see most victims are over the age of, or 18 or over. And so we've got this, but it's kind of stuck in our R Markdown folder file. And so we're going to save it. And the way we can do this is make another code block. You can put a header if you want, save plot to PNG, something like that. You're going to type Vic 18 and over plot. So it's going to be the name of our new object. And see, we're then going to repeat the code from above. So this whole thing, you should technically type it all out, but you can actually just do it like that. Or again, you can add spaces for aesthetic reasons. So we're saving that plot to an object. And then scrolling. We will use the ggsave command, which will save the file you just most recently, or the object you've most recently created. And we'll use the here function and then save it with your last name. In this case, it's a Ducate Vic 18 and over bin.png. I'm going to save it as a PNG file because that's an image file I like. You could do JPEG. That would work as well, but I tend to prefer PNGs. So it says saving 7 by 7 in image. If you want to see if that worked, you can go to your Files tab and go to the correct folder. It should have you in the correct folder by default, but if not, you can navigate it to it. And we can see that this was created just now. We click on it, ta-da, we have our file. And so you can then go back here, browse your local files, and upload your PNG. And that will complete assignment 4. So hopefully this was helpful. As usual, please reach out if you have any questions. I'm available on email. I'm available during office hours. You can make appointments with me outside of office hours. You can post on the discussion forums. I'm on the group me, like a bunch of ways to contact me. Please feel free to reach out if you get stuck. But hopefully this walkthrough helps you see sort of how to do these assignments.